Okay, today I'm gonna knock out some of these knockouts for my wiring between my two batteries and the wiring to the inverter. So I'm gonna just go ahead and I'm gonna knock out probably 3 of these 2-inch knockouts for now. I went to the big box store and got a metal conduit connector. Also got insulated plastic bushing, so you put that on the inside and it don't scrape the insulation in your wires. So we're going to go ahead and do that now. They look like they're fairly easy to knock out. Just smack them with my channel locks and pull it out. Looks good. So I'm going to go ahead and set this in here. Oh, so I already made a mistake. I knocked out one size too big on that one. So we're probably going to have to plug that one up. There we go. So the inner circle is for 2-inch conduit, maybe. Oh, look at that. That's very strange. It does not fit either side. That's relatively too big of a hole, and that's too small of a hole. So there's a little problem there. I'm going to have to figure that out. Actually, a special wrench. You can use a flathead or a Phillips head, but there's a conduit wrench that you can use that fits right in there, and there's a little square, a diamond in there to help accommodate that when you're tightening it down. So, a little change in plan because they only had 4 of these at the big box store. And that I have to use the second nut to secure it might become a problem. We'll see. And we also have the plastic bushing, which will go on the inside there. So your plastic bushing will just go on right like that, and then it prevents the insulation from being scraped down the metal of the conduit. This is pretty smooth, but I think per code you're supposed to have that. You put just, maybe I'll just have to put the ring on it like that. It's not the traditional way to do it. And then take another ring off another one and set it in there. So I suspect that they're metric. Put something in the back of it, that way I can slide the conduit box this way, put all the pipes in, all the conduit in going on this side, and then I'll slide the box over to it. And then the ridge is another 1 3/4 inches. So we'll call it 1.5 inches. we'll call this 6. 6, we'll call that 6. Yeah, it's almost 1 3/4, we'll call it 1 1/4. So 7 1/4. All right, got our battery positive, battery negative. Got our PV inputs. We got our ground. We got our neutral bus. We got our load and our grid. Now, since we're using it, we got our battery on and off. Then over here we got battery communications. We got paralleling. And it also shows our connections here. Right now I'm looking at the knockouts. I'm going to see what knockouts I'm going to take out. Probably both of these battery ones. Probably the PV ones here. And communications. Okay, so first of all, I went and got a couple different pairs of pliers. My first recommendation is going to be knock the knockouts out before you put it on the conduit box. Then, in my instance, the holes don't exactly line up. They're off about 1/4 of an inch. It's probably the walls not flat. These new houses, when they build them, they texture wall everything because they don't know how to make them flat, and it hides all the mistakes. So what I'm going to do is I'm just going to kind of push it in. First of all, I went to my bag of goodies that I got from EG4 or from Signature Solar with my conduit box. I got I'm going to probably just put one of these in here temporarily. That'll help me line the box up. Keep the box lined up. I did loosen up the bolts on the box to see if that would help, and it didn't. Now, I probably could use it in some of these, but we can see I can probably take this out and take the nut off here, see if it'll hold it in place. But I would feel good having at least one of these in here, because I'm not going to use them for anything else anyway, so I like that idea. We'll see. That did hold it some. I think if I put another one in, it'll probably hold it a little better. Yeah, I mean, it will hold it. It looks like I can see it's distorted some from the pressure, but we'll see. For right now, I'm going to use this. This thing's heavy duty, and they are metric. M63 by 1.5. The thread pitch. Yeah, I like that. I'm gonna have extra ones anyway, so I like that. It's nice and beefy. It just makes things all that more rigid. This thing isn't going anywhere. So I'll finish knocking these out, and I can use these for that I read in the manual. Shows you got to put 2 connections to it. Two positive and 2 negative connections. So think they should rethink the layout of how the terminals are on the flex boss as opposed to the battery, because all the negative terminals are on the left hand side of the battery, but the negative terminals are on the right hand side in the inverter. So you got to kind of cross them over. It would have been much nicer to see them come in on the left, come out on the left of the battery, come in on the left of the inverter, and go right straight up. I'm going to make sure that if I use the first plug on the battery here and I put it to the farthest to the right, then when I use the first plug on the battery on the positive side, I'm going to also put it farthest to the right. I don't think it makes any difference. It's just something that I do, probably just for peace of mind, or a little OCD maybe. Now, in our other videos, you don't ever see me torquing anything down. Well, you should torque everything to spec. I will definitely make sure this is torqued down to spec. Torque wrench is in foot-pounds and your specification is in inch-pounds. You're going to divide by 12. If your specification is in foot-pounds and your torque wrench is in inch-pounds, you're going to multiply by 12. Also, I've seen a number of questions where are you supposed to use a ferrule or a crimp plug? Anything that I saw showed just putting the wire in there, putting some no-ox on the wire, anti-corrosion, and then terminating the wire and torquing it down. So that's what I'm doing. I don't have any no-ox, but I have Copper Shield, which is Thomas and Betts version of no-ox. It's corrosion resistant compound. We're just going to take it and we'll put another one on there. All right. Now we'll take the electrician's version of anti-seize that you end up wearing all over the place, and we'll put it on the wire here. And I'm sure I'll get it all over like I did the last one, but that's okay. As long as it protects the wire from corrosion, I get a sufficient amount on there, I think we're going to be good. Alright. Boy, that sure does help when you're putting the wire in. And I'm not torquing it at this time. At this time I'm just snugging it up so it doesn't come out. I'll torque them all at the same time. There we go. I don't like how I did it, but I did get it in there. There's some extra wire here. Plug is in there all the way. Hindsight's 20/20. Hindsight's 20/20. Okay, so looks like we got these two terminals on. Now, the next one. A little tip. Before you mount the conduit box, put all your connections on your battery. Otherwise, it's going to be very difficult to make your connections. If you look, there are some small set screws right here. If think I can remove them out and that plate will come out. So there's a little release lever right here. When it's fully seated onto the connector, that should pop back out. It kind of snaps on, and that one wasn't out all the way, so I just tapped it a little bit with a hammer and it went right in. Probably wouldn't hurt a little lubricant on the O-rings. No trick about it. I didn't come up with it. Somebody else did. I saw it on other YouTube videos, and let me tell you, that's the way to go. Just get it up there pretty close. Don't have it too tight. I'm pretty liberal with it. Take it up in there. Okay. I knew I'd make a mess of this by the time I was done. I sure did. Last one always. There we go. We got it. We got it. Make sure it's in there good. I'm going to clean this up a little bit. I'm going to put okay. Looks pretty good. Alright, I'm going to get that torque spec. I'm going to torque them down. Pretty close. I think we're at 18.3 Newton meters. So I believe that's going to be sufficient. So I'm just going to go through here. There we go. There we go. You want to be smooth with your torque wrench. You don't want to jerk your torque wrench around. You could get false readings by aggressively torquing it. I'm going to go back through them again. There we go. From EG4 or from Signature Solar, when I bought my second battery, I also bought the parallel kit. It was $99. Well worth it. One connector's 20 bucks. So you'd have to buy two connectors anyway, and I don't think this cable would be long enough. Maybe it would. It's just much easier to spend the $99. I did go pick up my battery, so there was no shipping cost, and I also bought it when I purchased my battery, which was Good Friday when they had 10% off batteries. So I believe I got 10% off that cable. Run it behind all of the cable. Sneak it in here, like so. Pull the cap off and plug it in, and you could hear it snapping. So I'm pretty happy with that. And it snapped in, I could hear it snap. Okay, now the negative cam. Looks like I'm going to get lucky and it's going to fit through the conduit. Thank goodness. Then we'll run it over to the other side here. Snapped in good. I can see I'm blocking my conduit here, so that'll probably change. And it's that easy. I have the parallel kit hooked up for the 2 batteries. I have the battery connected to the flex boss. I'm just going to go ahead and put all the little screws back in here. I'll get the communication cable run. One thing I'd like to say is these are nice. It's a nice product line that they have. We'll see about performance very shortly. It's amazing. They have 64. Could you imagine having 64 of these batteries? That's a lot of money. Anyway, there you have it. Watertight connection for battery communications. If I use the one on the bottom right on battery number 2, I'm going to use the one on the bottom right on battery number 1. I will probably zip tie these up when I do all my final wiring. They're all installed. We got them torqued down. I believe it was 18.6 Newton meters max, or 165 inch-pound.